Today's pattern is on factoring polynomials. We're going to go through some old stuff. We're going to go through some new stuff about how to go ahead and factor, all types of polynomials, not just quadratics, okay? But to start, we're going to go ahead and we're going to review four basic concepts that are going to help us with what we're going through today, okay? So remember, to factor general trinomials, what you're looking at is you always take this out, take 32 out to the side, you do all the factors, 1 and 32, 2 and 16, all right, 4 and 8, and then you try and see which of these sets of factors can go ahead and add or subtract to get you this middle term right here, okay? So what I look at is I look at this, and in order to get a negative 12, I'm going to need a negative 4 and a negative 8. Okay, so all you do is you take and you break this trinomial up into two binomials. T here, because that's your t squared term. All right, then you take and you put the negative 4. All right, and then you take and you put the negative 8, and you have successfully factored that general trinomial. Okay, the second one is a perfect square trinomial. It's kind of the same idea right here. Take 36 out to the side, 1 and 36. All right. 2 and 18, 3 and 12, 4 and 9, all right, and then you got 6 and 6, okay? Now, what are we going to use to go ahead and get to 12 right here? Well, we know we're going to use a 6 and a 6, and it's a positive 6, positive 6. So for that one, you'd write it as x plus 6, and you'd write it as x plus 6. Easier way to write this is just x plus 6 squared. And there's a rule that goes with this one. If this last term right here, all right, is a perfect square, what you can do is you can take the square root of it. The square root of it's equal to 6, and then 6 plus 6, or 6 times 2 is going to give you that, okay? So you can just go ahead and take the square root of that last term there. Now, the difference of two squares, all right, we know that difference means subtraction, all right, and this one says of two squares. So I want you to look at your A term, I want you to look at your B term right here, and you know that this 4, x squared, is a perfect square, and this 9 is also a perfect square. So I'm going to go ahead and I'm going to take the square root of both of them, okay? And when I take the square root of both of them, my A value right here is going to equal 2x, and my B value right here is going to equal 3, all right? So what happens is when you have the difference of two squares, you can write it out like this, A plus B, and then you can write it as A minus B. So I'm just going to take my A term and my B term and put them in here. So my final answer for this one is going to be 2x, all right, plus 3. And then I'm also going to have 2x minus 3. Okay? If you were to go ahead and FOIL that out, 2x times 2x gives you 4x squared. Positive 3 times negative 3 gives you a negative 9. And then your x terms would cancel out in the middle. All right, so that's the difference of two squares. Now, common monomial factor, this one is what it sounds like. A monomial, we know, is a, one term. It's a polynomial with one term. So what we're going to do is we're going to look for what these two terms have in common. And right now, we're going to look for the greatest common factor between 10 and 30, which I know my GCF here. All right, between those two is going to be 10. Also, this one has x squared. This one has x. The most number of x's that we can take out of each of those is 1x. So I'm going to take, I'm going to divide this by 10x. I'm going to divide this right here by 10x. I'm going to factor it out, okay? And when I do that, right here, I'm left with x. And when I go ahead and cancel all my x's here, 30 divided by 10 is going to give me a positive 3, okay? Now, my greatest common factor, we take that, and we have to put it out front here. Okay, it doesn't just magically disappear. We factored it out. Okay, this right here, guys, would be factoring when you have a common monomial factor. Okay, now the sum of two cubes, all right, is different than the sum of two binomials. All right, it's different than the difference of two squares. And there's a pattern that goes with it, okay? And the pattern that goes with this one is you take and you break it up, all right? And when you break it up, it's going to look like this, okay? Your pattern is going to be, if you have a to the third power, b to the third power, you're going to factor it out as a plus b, all right? And then what you're going to have is you're going to have a squared minus ab, all right, plus b squared. So it's very important in this one to go ahead and be able to identify what your a and your b value are, okay? So in this one, I would go ahead and take the cube root of this, and I would take the cube root of this. All right, so to figure out what my a is, all right, my a, I'd take the cube root of that, which would give me x. All right, my b value, I'd take the cube root of that, so my b value here is going to give me, you're going to end up with 4, because 4 times 4 times 4 gives you 64. So now, when you go ahead and you factor this one, you're just going to put in parentheses your a plus b. So I'm going to have x plus 4. Okay? Now, in my second set of parentheses, this is when I go ahead and I get my quadratic binomial, a squared. Well, we know my a is x right here, so I'm going to go ahead and put x squared. Now, this says I have to go ahead and multiply these two, the a and the b, together. So this times this would give me a minus 4x. All right? And then I'm going to go ahead and I'm going to do b squared for my last term, so we know that b times b is going to give me a positive 16. That right there, guys, we went ahead and we factored the sum of two cubes. All right? The difference of two cubes is kind of the same idea. It has a pattern as well. All right? You're going to look for the cube root and the cube root of both your terms here. All right? And when you do that, the pattern that this one's going to turn out to be, it's going to be a minus b. And now in your second set of parentheses, you're going to have a squared plus ab, all right, plus b squared. All right, so I'm going to go ahead again, I'm going to find out what my a and what my b are by taking the cube root and the cube root. Okay, so, you know, w, the cube root of w to the third power, w times w times w, is going to be w. And then we want to go ahead and we want to take the cube root of 27, all right, which is going to be 3 times 3 times 3, all right? So my b value is going to be 3. So all we're going to do now, guys, we're going to go ahead and we're going to follow my pattern now, my factoring pattern, all right? W minus 3, just taking from my a and my b here, all right? Now I got to do my a squared. We know a is w, so I'm going to go with w squared. And then we're going to go ahead and we're going to add a times b. So if I multiply these two, I get plus 3w. And then I'm going to take and do my b squared in my last term, so I'm going to go with the plus 9. All right? Now, you're probably looking at this and saying, well, I want to go ahead and factor this. Well, what are your factors of 9? We got 1 times 9 and 3 times 3. Do either of those add up to be this? All right? And you recognize that they don't, so this is, all right, we're factored completely here for this one. Okay? Second thing. All right, special factoring patterns. Again, all right, we're going to go ahead and do something called factoring by grouping. And this is the rule. Oh, here's what I want you to do. We're going to cross off, this part. Okay, this is the rule right here for factoring by grouping. And I'll show you what we're talking about. The idea is to take and group two terms that have a common monomial factor. So I would go ahead and I'd group that, and then I'd go ahead and I'd group this. Okay? The reason that I group this is because the common monomial factor here is x squared. So I would factor an x squared out of this. And when I do that, I'm left with, if you took x squared out of there, you'd have x. And if you took x squared out of here, you'd have minus 2. Okay? So I went ahead and I factored out that common monomial factor. Now, with this one, what is the common monomial factor that they have in common? I would go ahead and say they have a negative 25, because this has a negative 25 in it, and this also has a negative 25 in it. So I'm going to go ahead and I'm going to factor out that negative 25. All right, and when I do that, what am I left with right here? Well, I'm left with x, and if you divide this by negative 25, you're left with minus 2. Okay, so take a look at what we have here. Take a look at this part that's a plus b, all right, and a plus b. Well, we got a plus b and a plus b. We got x minus 2 and x minus 2. So what happens now is you take this and you break it up. You take this monomial that you factored out and this monomial that you factored out, and you write it as x squared minus 25. All right, then you have this part, x minus 2, x minus 2. All right, you're going to go ahead and you're going to write that, all right, as x minus 2 only. So you've taken and you've broken this up into, you know, two sets of parentheses here. Now this one you should recognize is the difference of two squares. So if you wanted to factor this one, you could go x plus 5, and you could go x minus 5. All right, then you're going to bring down that x minus 2, and we have now factored by grouping. Okay. Factoring in quadratic form here, what you'll notice is 16, what's the square root of 16? 4. What's the square root of g to the 4th? 2. And then negative 625, if you took the square root of 625, it's 25. Okay? So for these ones, what you can do is you can go ahead and take the square root of both of these. All right? When you go ahead and you do that, you're left with 4g squared minus 25. And then you're also going to have 4g squared plus 25. Okay? You notice in the middle, guys, there's no g squared term. So it's almost like the difference. It's almost like this one up here, the difference of two squares. All right? Now what happens in this is now you actually have the difference of two squares right here. So if you were to break this up and take the square root of this and the square root of this, you're going to be left with 2g, right, plus 5. And you're going to be left with 2g minus 5. All right, because that was the difference of two squares right there. This one right here, all right, you cannot factor it anymore, so you leave it as 4g squared plus 25. And we have now factored this completely. Okay? Now, the last part is I want to take it a step further. Instead of factoring, I actually want to go through and I want to solve these when they're set equal to 0. All right? Now, remember, in order to solve these, you always want it equal to 0. Right? So I'm going to take this and I'm going to get it to the other side, and I'm going to rewrite this now as 2x to the 5th power minus 14x to the 3rd power plus 24x equals 0. And now I'm going to go through and solve and find the number of solutions here. Okay? Now we're thinking that with this exponent right here, we're supposed to have 5 solutions. But let's start factoring. All right? Common factor, 2, 14, 24. I'm going to factor out a 2. Okay? X to the 5th, x to the 3rd, x. I'm also going to factor out an x. When I do that, here you have x to the 4th left. Here, when you divide by 2x, you're left with minus 7x squared. And here, when you divide by 2x, you're left with plus 12. Okay? Now, if you wanted to go ahead and break this up, you have x to the 4th. So you could break it up as x squared, and you could break it up as x squared. Right? You go ahead and you cut that in half. Now, I'm going to take this out to the side, and my factors of 12 are 1 and 12, 2 and 6, right, and 3 and 4. Now, do any of these sets of factors go ahead and get you to negative 7? You know that minus 3 and minus 4 do. So I'm going to put those in here. Minus 3, minus 4. I'm going to bring this down 2x, and I know it's equal to 0. All right? So I'm going to rewrite here. 2x, x squared minus 3. All right? X squared minus 4 is equal to 0. This one right here we should recognize as the difference of two squares. So when you factor this one, you end up with x, all right, minus 2, x plus 2. Let me erase that, hold on. All right, it should have been plus 2. X plus 2. All right, and then you got your 2x, and you got your x squared minus 3 right here, and it all equals 0. I'm going to take and I'm going to set all these equal to 0 now, and I'm going to find my solutions. 2x equals 0. X squared minus 3 is equal to 0. X minus 2 is equal to 0. And I got x plus 2 is equal to 0. All right, when you divide this one right here, you get x is equal to 0. When you go to this one and add 2, you get x is equal to 2. And this one right here, you get x is equal to negative 2. Okay? Now this one, what happens is you get x squared is equal to a positive 3. And you take the square root of both sides. All right? And you end up with x is equal to a positive or negative root 3. All right, so take a look at my solutions now. X equals 0, x equals positive or negative root 3, x equals 2, x equals negative 2. You ended up with 5 real solutions there, which matches your largest exponent. Okay? Guys, those are the general rules of factoring polynomials and all polynomials. Some of it's a review, some of it's brand new, but really what I want you to focus on, guys, is remembering these special factoring patterns right here for the sum of two cubes and the difference of two cubes.